Hello and welcome to this lecture series on computer networks and communication. The concept of network is not very new. For many years, you have been hearing about different types of networks such as network of banks, network of railways, network of airlines and so on. In the recent years, you may be hearing about another new kind of network, that is computer network. This computer network has emerged as a convergence about two important technologies of this decade, of this century, that is computer technology and communication technology. In this lecture, we shall discuss and see how computer networks has evolved as a result of the merger of these two important technologies. We shall briefly discuss about the benefits, advantages of computer networks and some disadvantages as well. We shall also see some of the important applications that are emerging with the proliferation of computer networks. Finally, in this lecture, we shall give you an outline of the course that we shall discuss in this lecture series. To start with, let us see what do we mean by computer network. A network is an interconnected set of objects. These objects can be banks, cities, computers, as I have told. Now, whenever you consider a network of computers, we can define it in this way. A computer network is an interconnected set of autonomous computers. Here we see we have used a word called autonomous. What do we mean by it? By autonomous, we mean the computers are standalone. They can work on its own. They have their own hardware, CPU, memory, peripherals, and softwares, operating system and various application softwares. But they are interconnected such that they can communicate, the computers can communicate with each other for various reasons, which we shall discuss in this lecture. Now, coming to the history of computer networks, the computer networks did not come up in a year. It has gradually evolved. As I told, computer network has evolved as a result of the merger or happy marriage between two important technologies, communication and computer. Let us first concentrate on communication. Of course, people are communicating with each other from prehistoric ages, but the electronic or electrical communication started with the invention of telegraph in the year 1838 by Samuel F.B. Morse. The invention of telegraph ushered in a new epoch in communication. It started the era of electrical communication. After that came the invention of telephone by Alexander Graham Bell in the year 1876. Then there was the invention of radio by Marconi in the year of 1896. But as you know, recently it has been established that our Indian scientist Acharya Jagadish Chandra Bose is the actual inventor of radio. But of course, the name has gone to Marconi because of some historical mistakes. Anyway, then in the ensuing years came the development of television in the year 1923. Then came microwave, satellite, and various other technologies which are emerging. in the area of electrical communication. Let us now change gear to see what has happened in computer industry or computer science. The history of computer is not as old as electrical communication. The history of computer is only 50 years old, about 50 years old. The ENIAC, the first electronic computer, was developed in the year 1946, and in the first 2 decades of its existence, computer remained as a centralized computer system. And of course, it has evolved. Let us see how the scenario of centralized computer system has evolved over the years. In the early years, the scenario was like this. That means in 1950s, the computers were made of vacuum tubes. They were very large in size, consuming lots of power. They were operated by trained personnel and like programmer, system analyst, system programmer, and so on. To common users, computers were a mysterious object. Common users had no direct link or direct communication with the computers. If they wanted to submit some job, they were standing in a queue outside a window, and the jobs were submitted in the form of usually card decks. And these jobs were submitted to a card reader, which were read one after the other in batch mode. And executed by the computer one after the other, one at a time. And the results were printed on a printer, and outputs were submitted maybe on the next day through another window. Obviously, people were standing in queue to receive the results. And if there was any mistake, they have to correct it. Maybe next day, they will again submit the corrected program, and again it will be run on the computer. They will receive the result. So as a result, if the program is not correct, it may take several iterations, and it may take few days. So there was long delay in after submission of the result, after submission of the program and receiving the result. Obviously, this was not a very good situation, not acceptable to the users. So scenario changed in 60s, particularly because of some advancement in the transmission technology, communication technology, and also because of the invention of transistor in 1947. Invention of transistor acted as driving force for the development of communication technology as well as for the development of computers. So computers became little smaller, and many people were able to afford computers now. However, computer use also changed in some way. For example, computer is now can be housed separately, and the terminals, peripherals, they can be linked by low speed links, and communication can be done through these links. That means here the situation is the users are directly communicating with the computer. As we see, here are the terminals linked by low speed serial links, and these terminals are called interactive. Why interactive? Because the users can now enter their program, execute their program in an interactive manner, correct their program directly on the computer. They don't have to submit to a programmer, get the result next day, and so on. So it is a big step forward compared to this scenario. But still, the computer is a centralized computer, that you have got a single computer, maybe a large number of terminals, interactive terminals, distributed in a campus or in a big building, which can be used by different people. Then the number of terminals increased to so much that it was necessary to have special type of equipment like multiplexer. Muxes are essentially multiplexers. And another equipment that was used is called front-end processor. Here is your computer. This is a mainframe computer like the previous ones. And this is the front-end processor. What this front-end processor is doing, it is uploading the job done by the computer for communication with peripherals like printer and these terminals. So here these muxes were acting as some kind of concentrator, accumulating the signals and sending to the front-end processor. Front-end processor was responsible for receiving and sending with the peripherals and terminals, and the computer was mainly performing data processing. So this is how a simple network was set up, but still it is a centralized computer system. In the strict sense, we cannot call it a computer, a network, because you have got only one computer. You don't have many computers. Then came another scenario. Because of the invention of IC, integrated circuit, in the year 1957, semiconductor device technology was advancing at a fast rate, creating low-cost equipments and communication equipments. And that time, the Cold War was at its heights. War is bad, Cold War is worse. But war has some positive aspects as well. In the 1970s, particularly in 1967, the Department of Defense of America gave projects to universities and research organizations to develop a network for communication and control which will survive the nuclear war. So the basic technique that were used earlier based on telephone network, which uses circuit switching technique, was found to be unsuitable, because in circuit switching technique, if a link fails, the communication is disconnected, disrupted, and that is not acceptable in war and various other situations. So they gave projects, and using those projects, a computer network developed called ARPANET. ARPANET stands for Advanced Research Project Agency Network. That Advanced Research Project Agency gave projects to universities and research organizations to develop the network. And here you see a rudimentary form of that network, which was developed in late 60s, where they used a special type of equipment called IMP, interface message processors, which are acting as some kind of switch or routers. They are some kind of computer, but their function is not data processing. They were used for the purpose of switching, for communication between, say, here is a IMP, here is another IMP. So if a data has to come from this host to this host, that will travel through several IMPs. So IMPs were acting as some kind of switches or routers. And to achieve reliability, the suggestions that were made is the IMPs were at least each IMP were linked to more than one IMPs, at least two IMPs, as you can see in this network. And another concept, revolutionary concept, which was developed and used in this ARPANET is packet switching. Later on, we shall discuss in detail what this packet switching is, and we shall see why it is more reliable than the circuit switching. In packet switching, if this link fails, then the packet can be sent through another path. So what is done in this? A big message is divided into small packets, and those packets are sent independently. One may be sent through this path. If this path is disrupted, the another packet can be sent through this path, just like the postal system. We shall discuss about in more detail later on. Then gradually various softwares were developed, which are called protocols, for communication between two IMPs, between two IMPs connecting the source host and destination host, and for communication between two hosts. And that software protocol culminated in the development of TCP/IP, Transmission Control Protocol, Internet Protocol. This Transmission Control Protocol and Internet Protocol is the software which is acting as a glue to link different networks together. And we shall see that the various concepts, technologies, softwares which are developed in ARPANET are used even nowadays. So ARPANET can be considered as the forerunner of the modern computer network. And after this development, it was found that now in 1971 there was development of microprocessor, invention of microprocessor, where it was possible to put the complete central processing unit on a single silicon wafer. So that acted as driving force for the development of computers and communication equipments, and very fast computers were developed, their costs were reduced, workstations, servers, personal computers were developed. Now a single organization could own a large number of computers of different types, mainframe computers, mini computers, workstations, servers, personal computers, and so on. It was felt that necessary was felt for the development of faster communication technique, and technology like packet radio. In the University of Hawaii, packet radio technology was developed. Ethernet technology was developed in the year 1976. Cambridge ring was developed in 1979. Actually, these are essentially local area networks. For example, Ethernet, which was developed in Xerox's Palo Alto Research Center, where you have a bus technology on which a number of computers can be linked, and then they can share a single medium, a protocol called CSMS-CD, Carrier Sense Multiple Access with Collision Detection, was developed so that a single medium can be shared by a large number of computers, and they can communicate at the rate of 10 megabits per second, which is much faster than the telephone technology. For example, in ARPANET, the communication links were established by telephone networks, and these were essentially, say, 3 kb, kilobits per second, these links, and these links were maybe 56 kilobits per second using leased lines. But that was not good enough. That's why here it is much higher, 10 megabits per second. And in 1979, a Cambridge ring was developed in the University of Cambridge, where the topology was a ring and a number of computers can be linked to this ring, and a protocol called token passing was developed. Later on, we shall discuss in detail about these Ethernet and token ring technology. Now, that was in the year of 1979. After that, 2 decades have passed, and in the last 2 decades, lots of new developments have taken place. Both computer technology and communication technology has evolved, speed has increased, size has reduced, faster and faster computers and communication technologies were developed, and now we can broadly categorize the computer networks into 4 different types: LAN, local area network; metropolitan area network; wide area network; and internet. LAN based on these parameters: area, speed, reliability, and owner. Local area network, area is limited over a small geographical area, maybe from say 10 meter within a room to maybe few kilometer, say 5 to 6 kilometer. Speed varies from nowadays 10 megabits per second to maybe thousands of megabits per second. And the local area networks are highly reliable, maybe 1 in 10 to the power 11, and these are usually privately owned. Private. All the local area networks are privately owned. On the other hand, wide area networks, the area can vary from say 10 kilometer to maybe 100 kilometer, encompassing a country or a subcontinent, and speed can vary from say few kilobits per second to maybe tens of megabits per second nowadays. And reliability is low, and the wide area networks are owned by state. Of course, scenario is changing. Nowadays, some wide area networks are owned by private companies as well. And in 1980s, metropolitan area network was developed and proposed. Technology is very similar to LAN, but the area that it can cover can be say 10 kilometer, a complete city, and the standard that has emerged is DQDB, distributed queue double bus, which we shall discuss in detail later on. Speed can be about say 10 megabits per second. Reliability is moderate, and the owner is usually private. This internet, which we are hearing nowadays quite often, is not really a new networking technology. Internet can be considered as a network of networks. Here you have got different types of networks like local area network, wide area network, local area network, which are connected by equipment like routers, bridges, and gateways. And these networks are linked together by software protocol called TCP/IP or UDP, Transmission Control Protocol and Internet Protocol. Later on, we shall discuss in more detail about this equipment as well as the software protocol TCP/IP. You may be asking why computer network is becoming more and more popular. Why the proliferation of computer is taking place at such a high rate? There are various reasons. Let us see the advantages and benefits of computer network. First one is resource sharing. You can share costly resources, equipments, programs, data located at distant places, irrespective of irrespective of where it is actually located. You can share it in a very convenient way as if it is available close to you. And for example, you can have a costly color uh, laser printer. If it is on a network, all the computers on the network can share it. You have got a special database which can be shared. So resource sharing is one of the important motivation behind computer networks. Another is high reliability. In a centralized computer system scenario, if this computer fails, everything will collapse because all the terminals, printers are using this centralized computer, and all the computing is done by a single computer. On the other hand, in a computer network scenario, you can have a large number of computers. You can replicate or duplicate software, database, and various other resources. And if one or more computer fails, still the work will go on, maybe with some degraded performance, but it will provide you higher reliability. Then it has been found that a computer network gives you lower cost. You can implement same computing facility at a lower cost. It has been found that suppose a particular computer gives some performance, say a workstation gives some performance, you may get 10 times more performance from a mainframe computer, but for that you have to pay 100 to 1000 times more. So if you can implement a network of computers which will serve your purpose or computing requirement, you can do it at a much lower cost using computer networks. Then scalability. Scalability is very important in the present day scenario. Your requirement is gradually increasing. Your database, the complexity of the programs that will be executing is increasing day by day. So as your requirement increases, in this scenario what you have to do, if this computer is not able to serve your purpose, you have to throw it out, declare it obsolete, and you have to buy a new computer. And that is a very costly process. As you know, replacement of a computer and deployment of a new computer requires lots of investment and effort, which can be avoided in a computer network scenario. If a computer has to be, if your need is more, you simply buy another computer, powerful computer, add it on the computer network and use it. So as a consequence, you can keep on increasing in an incremental manner the various resources, computer, peripherals, software, and various other things in a scalable manner. So the computer networks provide you scalability. Finally, it is very flexible because you can plan your requirement and gradually keep on increasing in a flexible way. You can optimize the cost and various other things, and that's why computer network is becoming more and more popular. But unfortunately, in this world, nothing is one-sided. You have got some disadvantages as well. One important disadvantage is loss of control. You have got large number of computers, heterogeneous computer environment with different types of hardware, software, databases, and so on. So it is very difficult to enforce some standard or control the entire thing in a effective way. So control becomes more difficult in computer network scenario. Then there is loss of privacy. You are no longer a isolated computer. Your computer is on the network, so other can access the programs, database, and various other things which you have developed, and they can access it. As a result, there is loss of privacy. What can happen? The software, database, and various other resources that you have developed is now exposed, and hackers and various other people can try to destroy or damage your resources. And that's why security and protection becomes a problem, and you have to develop suitable security and protection mechanism so that you can protect your software, at the same time share the resources in a controlled manner. Now, because of the computer networks, various applications are emerging using the computer network environment. As you know, the computers were developed for scientific and technical computing, but the scientific and technical computing can now be done in an altogether different manner by using computer network. For example, you can deploy client server model. In other words, because of computer network, availability of computer network, client server model or client server paradigm is becoming widespread. What is client server paradigm? Here you have got several servers, and you have got a large number of clients like personal computers, and servers can be servers and big workstations. A client can send a request message, and the server will process it and send the reply message through the computer network. That's how this client server model works. Later on we shall discuss more about it. Then you can do distributed processing. You can distribute your processing power. You can distribute your database on a large number of computers and do the processing. And computer network facilitates distributed processing. For example, applications like railway reservation is an example of distributed processing. Then parallel processing. As I told you, in a computer network you can achieve performance at a lower cost. That has led to parallel processing in a computer network environment. If you want fast processing power, high processing power, you have to buy a supercomputer. But it is now established that you can achieve supercomputer like performance by using a cluster of workstations linked by high speed local area networks. What you do in this, you divide a big task into smaller tasks and distribute it over a large number of workstations, and by using parallel processing you can achieve the performance very close to supercomputers but at a much lower cost. And that's why the network of workstation now project is has become very popular. Then computer network is providing a very powerful communication media. If several persons located in different places, maybe one in USA, another in India, they are suppose writing a report or a technical paper, they can communicate over telephone computer network, and they can write the project or the technical paper using the computer network in a very effective manner. Then virtual LAN is another concept where a large number of users located in different places will form a logical group as if they are located very close and communicate in that manner. Later on we shall discuss in more detail about this virtual LAN. And another important application area is commercial. The commercial applications are gradually have exceeded the scientific and technical applications. Computer network can be used for advertisement. There are various websites where the advertisements are made, and if you search any website, you will find lots of advertisement are displayed. So then telemarketing, one can place order by looking at some product on a website. So through a computer network, telemarketing can be done. Electronic commerce, e-commerce is becoming a buzzword. So lots of business can be performed through computer network. Then teleconferencing, another commercial application, which is nothing but virtual meeting. You don't have to travel long distances to meet or uh, to for the purpose of meeting, and in sitting in your own room you can talk, you can see what the other person is talking, and teleconferencing is becoming increasingly popular where you can do virtual meeting without traveling long distances. Then worldwide financial services can be implemented by using computer networks. But what is more important, what is becoming more and more popular, is the use of computer network for people. Now, computers are used for distance education. You don't have to go to universities, sit in a classroom to attend lectures. Sitting in your house, you can go through the lesson available through computer network and then maybe appear for exam. Then telemedicine. In the healthcare, computer network is playing a very important role. You can get expert advice through computer network sitting in your own home, or an expert surgeon can advise, can guide a surgery located in remote places. So that type of thing is becoming widely popular because of computer networks. Then access to remote information. Because of the popularity of World Wide Web, you can wander around wealth of information in different websites on various subjects like sports, medicine, education, and whatnot, and access information most of the time free of cost, and that's how you can increase your knowledge. Then person to person communication can be done. Email, electronic mail is becoming very popular. Nowadays very few people write letters and then send it through postal and telegraph. Dozens of emails are sent by an individual and they receive dozens of email, electronic mail, for person to person communication. Another important application that is emerging is interactive entertainment. Multi people video games can be played which are very exciting and becoming popular sitting in your own house. Then video on demand. If you want to watch a particular movie, or maybe you want to change the movie in your own way, that will become that will be possible in near future. So video on demand will become popular, and these are the various applications which are emerging, and obviously the application domain is limited only by imagination. With time, more exciting and exotic applications will emerge, and computer network will make it possible. Now, it is my privilege to introduce to you such an exciting subject which has merged information, communication, and entertainment. The objective of this course will be, or lecture series will be, to provide the knowledge of data communication and computer network in a unified manner. The subject is massive, so I have tried to divide the subject into several modules, understandable modules, and then present that one after the other, giving information about the state of the art. The entire course has been divided into four distinct modules, or 4 distinct parts: data communication concepts, wide area networks, local area networks, and internetworking. So these are the 4 broad areas in which I have divided my lecture series. In the first part, data communication concept, we shall discuss how data which you want to communicate can be converted, transformed into different types of signal which can be communicated through a computer network, through a transmission media. So in this part we are restricting communication between a pair of users. You have a sender and a receiver connected by a transmission media. We shall discuss about different types of transmission media, different types of impairments that the signal suffers while passing through the transmission media, and what kind of encoding you have to do, data encoding you have to do for efficient communication through a transmission media, and what kind of multiplexing techniques that you can do for efficient use of the bandwidth of the transmission media. In spite of all these things, error will occur, how you can detect error, and how you can control error. These are the things we shall discuss. We shall also discuss how you can interface your equipment to the media, transmission media. So these things will be covered in the first part. In the second part, which is wide area networks, we shall consider different wide area network technologies such as X.25, packet switching, frame relay, and ATM, and the underlying concepts, related concepts related to wide area networks such as circuit switching, packet switching, flow control, congestion control, routing techniques. These are the concepts which are used in wide area networks. These we shall discuss in part 2. In part 3, which deals with local area networks, we shall consider various issues related to local area networks such as transmission media, topology, medium access control techniques, because as I mentioned earlier, we will be sharing a single medium and we have to develop suitable medium access control techniques for sharing the medium, and some standard legacy LANs such as Ethernet based on CSMA/CD, token bus, token ring, and so on. Then the latest developments leading to high speed LANs such as 100 VGNE LAN, fast Ethernet, gigabit Ethernet, and FDDI. All these things we shall discuss in this module. And finally, wireless LANs which are gradually emerging. The part 4, which deals with internetworking, we shall discuss about various equipment which we use for the purpose of internetworking, and the software TCP/IP, various protocols part of TCP/IP we shall discuss in detail in this internetworking section. Apart from that, there are some miscellaneous topics like network security, virtual LAN, structured cabling system, networking equipment, which are important and practical aspects for implementing a computer network. We shall discuss as miscellaneous topics. So in my next lecture, we shall start with the first one, how the data is converted into signal, what is data and signal. Thank you.